In this video, I just want to talk a little bit about references and arrays. The first thing that you need to know about references is that, we have these primitive types versus reference types. A primitive type is your ints, your doubles, floats, booleans, characters. Anything with the lowercase letter as a type is typically referred to as a primitive. It could be a long, short version of a data type. Generally, if it has a capital letter like a string or a capital integer or a capital double, those are reference types. And the difference between a primitive type and a reference type is that primitive types have, basic functionality associated with them. They can store data in a particular location in memory, and there's a set of operations that can be performed on it: plus, minus, divide, multiply, etc. For other types, reference types, you have many more operations that can be performed, such as parse int, parse double, etc. All right, so the thing that you have to recognize about storing a number in memory is that, for example, in this example, we're storing 256 in the variable n, and remember, an integer is 4 bytes. All right, so the memory would look something like the following. All right, this is just the binary storing 4 bytes of 256 in memory. So n is the location, and it takes up 4 bytes inside of memory. All right, so for the sake of explanation, we could just say that n, the location of n is 256, and let's just say it's in location 1001. Now for reference types, in C++, there's this concept of pointers where one thing can point to another, but that actually caused more problems than it added solutions to. So Java eliminated this idea of a pointer in Java and instead just added in the concept of a reference. So, like I said before, the capital type integer is an example, and it has things like parse int inside of the reference type. All right, what's the difference between the actual storage is that in a primitive data type, we actually have the memory location with the value stored in it. In a reference type, you have the memory location of the object that you want to store. So in this case, let's say that I had a capital integer I with a capital I, and it was a variable x that had this value 10 stored in it. Again, this isn't a primitive data type, so the capitalized I indicates that. So what actually happens in memory is we have this location marked x that has another memory location with it. I'm just making up numbers here for the sake of being able to store them, and that's 1102. So then in location 2010 is where we actually have the variable stored. Now, again, whatever size integer is, that's how much space this would take up. All right, so whatever size a capital integer is, that's how many bytes in memory this would take up. For the sake of explanation, we generally just say that it takes up, a memory location or a set of memory locations that is large enough to hold the value or values in that particular object. All right. So, this location references the beginning of where the value is actually being held. All right. So, for example, in this case, suppose that I had an object here that had a person. All right, a person object. And in this person object, I called this person object Homer. What's actually stored in the local memory here is the location of where the object begins. Because remember, we have to be able to allocate enough space in memory in order for this Homer object to be able to be stored. So, we have things like the name, the age, the phone number, all stored in memory. So what happens is, at the beginning, we have this reference to somewhere else in memory that has the sequential list of items that are going to hold Homer in it. So we have a 3620 here. Okay. Now, arrays are a very similar approach to this. All right. Arrays, let's say that I had a person array. And remember, I indicate that an item is an array by placing the two brackets there. So I declare something called people array, and I instantiate an array of 5 objects. Notice, because these are actual objects, I have to go through and actually instantiate each object. So not only am I creating the array, I'm declaring and creating the array by using the new, but then I have to instantiate each object within the array itself. So, for example, I just use this for loop that starts off at 0 and goes to 4, basically, and I instantiate each one of the objects. So inside of memory, what this would look like is somewhere I'm going to have something called people array, right? And then I'm going to have people array of 0, 1, 2, 3, and 4, because remembering all arrays always begin with 0. So I would have, the instantiation of person object 1. Well, maybe person object 1 is actually a reference to another location. Right, now the data could actually be stored in here if this was maybe an array of integers or something like that. It would store it sequentially. But since this is an array of objects, I can actually store them references. So I'm actually storing a reference to the array, and then each object is a reference to another location within memory. So you just kind of have to keep this in mind, that you're referring to different things, so that when if you're going to change something, or you assign one, people array of 0 equals people array of 1, you know that they're now referring to the same person object in memory. All right, so just keep that in mind. That's going to conclude the references video. I do encourage you to take some time and look at array lists as well.